Hi, and welcome to lesson 1.3, use midpoint and distance formulas. So obviously from the title, you can probably guess that we are going to be looking at two main ideas, one being the midpoint and midpoint formula, and the other being the distance formula. So to start with the midpoint, we are going to first have to make sure we understand what the definition of a midpoint is. So a midpoint is, quite simply, the point that divides a segment into two congruent segments. So what you could think of that is it's the point that breaks the segment in half. So it divides it into two equal parts. So, based on that definition of a midpoint, we then can explore the midpoint formula. So, the capital M here in the midpoint formula simply stands for the midpoint. And the midpoint formula is written as an ordered pair, in this case, an x and y coordinate setup. So, our ordered pair setup includes our equation. So the midpoint formula says the midpoint equals x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. Now remember the x sub 1 means one of our x values from one coordinate, and the x sub 2 means the other x value from another coordinate. So if we look at an example to make sense of that equation, remember all coordinates are always written x comma y, so x coordinate, then the y coordinate. So if we have the ordered pairs of 3 comma 2 and 7 comma 6, so those are my two different ordered pairs. To use the midpoint formula, m equals our two x values, so 3 from the first one, 7 from the second, 3 plus 7 divided by 2, comma, and then our y coordinates, so 2 and 6, 6 plus 2 divided by 2. And because it's addition, the order does not matter for the 3 and the 7, or the 6 and the 2. We can reverse order in addition. So what that is, 3 plus 7 is 10 divided by 2, gives us the x value of 5. 6 plus 2 is 8 divided by 2, gives us the y value of 4. So our midpoint is at the coordinate 5 comma 4. So if we drew this as a line segment, this would be our midpoint. Now the next piece is the segment bisector. So a segment bisector, to begin with, to break down the definition, we know it will involve a segment, and to bisect something, a bisection or a bisector, to bisect something means to cut it in half or to cut something at its midpoint. So a segment bisector can be a point, a ray, a line segment, or a plane, so many different figures, that intersects the segment at its midpoint. So a segment bisector is any of these figures, point, ray, line, segment, or a plane, and it intersects a segment at its midpoint. So example 1 will be making sense of these ideas and putting them together. So example 1 first helps us understand that idea of a segment bisector. The problem says in the skateboard design over here at the right, VW, so segment VW, bisects segment XY. So XY here is being bisected by VW. And that occurs at point T. So in this case, point T would be the segment bisector of segment XY. It is also the midpoint. So we could also say segment VW is the segment bisector of segment XY, meaning it splits XY into two equal parts. Now, the way we know that the parts are equal by looking at a diagram, it's a little hard to see on this one, but this little hash mark here and this little hash mark here tell me from the diagram that that segment is congruent to that segment because they both share the same hash mark. Now, what we know is the length of XT is 39.9 centimeters. So I just took this drawing and moved it over here to make it easier to see. I know X to T was 39.9 centimeters. Well, I know point T is the midpoint, so I know TY is the same length as XT. So TY would also be 39.9. So in order to answer the question of finding the distance of XY or segment XY, we would take XT, 39.9, and TY, 39.9, and add them together, or 39.9 times 2. That gives us the total length of 89.8 centimeters. Example 2 says, use the sketch to answer the questions. So this sketch over here, these two sketches, will go with A and B. So we're looking at these two over here on the right. So for A, it says point M is the midpoint of segment VW. Find the length of segment VM. And remember, this little dash above means segment. So if I'm looking at this diagram, M is the midpoint, so I know VM is equal to or congruent to MW. Now, these numbers didn't print great, so what they tell us, though, is this is 4x minus 1, so VM is 4x minus 1, and MW is 3x plus 3. Because I know M is the midpoint, I know these two sides are equal to each other. They're congruent. So in order to answer this question, I need to start there. I have VM equal to MW, or 4x minus 1 equals 3x plus 3. Then we want to solve for x. So we could subtract 3x from both sides of our equation, and we get x minus 1 equals 3. Add 1 to both sides, and we get x equals 4. Then to figure out the length of segment VM, because that answers what x is, but segment VM was 4x minus 1. So we need to take that value of 4 and plug it in for x. So our 4x minus 1 is 4 times 4 minus 1. 4 times 4 is 16. Minus 1 tells us the length of segment VM is 15. Then, in example B. Example B is asking us to do two different things based on this diagram over here. First, it's asking us to identify the segment bisector of PQ. So the way I know PQ is being bisected, hash mark here and hash mark here means PM is congruent to MQ. So what is bisecting it would be ray MN. Endpoint at M going toward N, so we would have to write that as ray MN. Then, to figure out the second part of the question, it asks us to find PQ, the distance of P to Q. So in this case, the distance of P to Q can be figured out based on knowing PM and MQ are the same. So if I add those together, or double one of them, I get the answer for PQ. So in this case, I have 1 1/8 plus 1 1/8, or multiplied by 2. So that gives me 2 1/4. Then, moving on to example 3. In example 3, the direction says use the midpoint formula to answer the questions. So A tells us the endpoints of segment RS are coordinate R is at 1, -3, and S is 4, 2. They would like us to find the coordinates of the midpoint M. So to figure out that, we go back up to our midpoint formula right here, and we need to add the x values, divide by 2, add the y values, divide by 2. So we'll go back to A here, and we'll take our x values, 1 and 4, add them and divide by 2, and our y values, -3 and 2, add them and divide by 2. So that gives us the points of 5/2 and a -1/2. Now it's okay to leave those as improper fractions. If you wanted to write this as 2.5, comma, -0.5, that's the same exact thing. Now in B, it says the endpoints of segment AB are A at coordinate 1, 2, and B at the coordinates of 7, 8. Find the coordinates of the midpoint of M. So we're going to add our x values, 1 and 7, so 1 plus 7 divided by 2, and add our y values, 2 plus 8 divided by 2. So that gives us 8/2 and 10/2. Both can be simplified. 8 divided by 2 is 4, 10 divided by 2 is 5. So our midpoint of segment AB would be at coordinates 4, 5. Now in C it tells us the midpoint of segment JK is at the coordinates 2, 1. And then they tell us one of the endpoints, which is 1, 4. Now they would like us to find the coordinates of the other endpoint K. So in this case, they give us the midpoint and they give us one endpoint. We need to find the other. So the way we do this is we take the parts of the midpoint formula and kind of work them backwards to find our missing x and y. So what we know is we know one of our x values and we know the final midpoint value. So we're going to take that midpoint value from here, 2, and we'll take the x value from here of 1. So then it would be 1 plus our missing x value divided by 2 equals that midpoint x value of 2. Then we solve for x. So we would multiply both sides by 2 to get rid of the 2 on bottom. So 2 times 2 is 4. And then we'd have 1 plus x equals 4. So we would subtract the 1 and x equals 3. Then we do the same process to find y. We know our final midpoint value for y is 1, and our endpoint value for y is 4. So our endpoint value of 4 plus our missing y value divided by 2 will equal 1. Then we need to solve that for y, so we'll multiply both sides by 2 to get rid of the 2 on bottom. So then we'd have 4 plus y equals 2. Subtract 4, 2 minus 4 gives us y being a -2. So then our x was a 3, y was a -2. So in that case, our other endpoint of k would be at the coordinates of 3, -2. And for D, it asks the same process to find an endpoint. So they give us the info. Midpoint of segment VW is at the point of M, which is coordinates -1, -2. The endpoint W has coordinates of 4, 4. Find the coordinates at endpoint V. So then we're going to take our known x value from one endpoint of 4 and add it to our missing x, divided by 2 equals our midpoint x value of -1. Solve that for x, so multiply by the 2. That would be 4 plus x equals -2. And then subtract 4, -2 minus 4, x equals -6. Then we do the same with the y's. We know our endpoint y is 4. So 4 plus our missing y value divided by 2 equals our midpoint y value of -2. Then we need to solve for y, so we multiply by 2. 4 plus y equals -4. Subtract 4, -4 minus 4, y equals -8. So then our other endpoint of v is at the coordinates -6, -8. Then the other main idea for this lesson is the idea of the distance formula. And you can see the distance formula here. It's represented with a lowercase d. So lowercase d equals the square root. So the whole thing is under the square root. And then it's in parentheses, x sub 2 minus x sub 1, end parenthesis to the second power, plus, in parentheses, y sub 2 minus y sub 1, end parenthesis to the second power. So it's our change in x values squared plus our change in y values squared added together, and then the square root of that whole piece gives us our distance. And this is something that you should have gotten an exposure to in Algebra 1, and now we're coming back to build upon that. So we're going to apply the distance formula in example 4. So part A says, what is the approximate length of the distance of R to S, and the endpoints of that segment R are at 2, 3, and S are at 4, -1. And again, remember, all coordinates are given to you in x, y. So our distance formula here, x sub 2 minus x sub 1. So I'm going to start with the s coordinates. So that will be my x2 and my y2. So I would have a 4 here and a -1 here. If you wanted to start with r, that's fine, but if you start with the value from r here, you'd have to start with it here. Same with s. If the value from s comes first here, it has to come first here. So our other x value is 2, so we have 4 minus 2 squared, plus, just using the formula, and then our y's, -4 minus 3 to the second power. So then, following the order of operations, do our math inside the parentheses first. 4 minus 2 is 2. -1 minus 3 is -4. Both are still to the second power, all inside the square root. Then, 2 squared is 4. -4 squared is 16. 4 plus 16 gives us the square root of 20. So our answer exactly is the square root of 20. If we type that into a calculator, we can answer that our distance is approximately 4.5 units. So that approximate length of R to S is approximately 4.5. So in B, we'll do the same thing. They want us to get the approximate length of A to B, and we know the endpoints are A being at -3, 2, B being at 1, -4. So we are going to just plug those in to our distance formula here. So in this one, I'm going to start with A and then B second. So change in X, -3 from the A minus 1 from B squared plus the change in Y. Because I started with the -3, I have to start with this one, the 2, minus -4 to the second power. -3 minus 1 is a -4. 2 minus a -4. Remember, if we were subtracting a negative, we change that to adding a positive. So that's 2 plus 4, 6. So then we have -4 to the second power plus 6 to the second power, all inside the square root. Do our squareds. -4 squared is 16. 6 squared is 36. Do our addition. 16 plus 36 is 52. So our distance is equal to the square root of 52. So our exact distance would be the square root of 52. To get our approximate length, we type square root of 52 into our calculator, and our distance is approximately 7.2. And then example 5. In example 5, doesn't matter which ordered pair you choose to substitute for the first coordinate and which you substitute for the second. Explain. So they're asking, does it matter which ordered pair we use for our first or our second coordinates? And just like I said, no, it does not matter as long as you keep the same order for both the x and y values. So again, if I started with our coordinate from A for the x, then for the y, I also have to start with the value from point A. Can't switch it to B and flip it for the other. So as you work through the practice problems, your two main pieces you want to remember for today, the distance formula and the midpoint formula. And then again, make sure you understand that idea of a bisector or segment bisector, meaning it's bisecting or intersecting a segment at its midpoint.